Welcome to this Tech Talk Live on legionella and scalding prevention in commercial environments. My name is Paul Harmer. I am the Technical Director of the CIPHE, and I'd like to hand over now to Stephanie Beck at Reliance Water Controls.
Hello, I'm Stephanie Beck, Product Development Manager for Reliance Worldwide UK. Reliance Worldwide are a global expert in the design and manufacture of advanced water controls and is one of the world's largest manufacturer of thermostatic mixing valves, with in excess of 1 million valves being manufactured every year. We are fully committed to raising the industry standards to ensure that our thermostatic controls are always fit for purpose and the public are therefore protected from scalding injuries. Every plumbing system presents conflict. Water stored at high temperatures kills bacteria that can cause scalding, whereas water stored at a cooler, non-scalding temperature is an ideal breeding ground for bacteria such as legionella. Today I want to talk to you about scald prevention in commercial environments. Legionella is a bacteria which can be found in most natural water sources, such as rivers and lakes, but in this environment it is at a low level and only really raises a threat to people's health in purpose-built water systems, like cooling towers, spa pools and hot water systems, as these conditions are usually favourable to the bacteria and help it to grow and multiply, which increases the risk of Legionnaire's disease. As you can see from the table, if we talk about cold water systems, so below 20 degrees, the Legionella can survive, but it is dormant. If we look at increasing that temperature between 20 and 50 degrees, then its optimum growth is at 37 degrees, and this is where it becomes more of a harm to people's health. And if we talk at even higher temperatures, 70 degrees and above, then we're looking at thermal pasteurisation temperatures, so the bacteria will be killed off instantly. Every year, over 500 people are admitted to UK hospitals suffering from severe scald injuries, with 90% of these being children. In addition, more than 20 people are killed every year by being immersed in hot water, with the majority of these instances being the elderly. By using a thermostatic tap, you can run the hot water system at high temperatures, circulating at no less than 55 degrees to ensure the bacteria is killed off. But at point of use, use a thermostatic tap to ensure the temperature of the water to the end user is at a safe, controlled level, which will not be harmful to them. This is especially important in high-risk environments, such as nursing homes and hospitals, where the users may not be able to communicate or even recognise the risks. Our CareMix thermostatic taps take a hot and cold supply inlet and mix water to a safe, controlled outlet temperature. The tap incorporates a temperature-sensitive element made from wax and copper filings, which reacts to changing water temperatures on the incoming supplies. The valve also has the ability to fail-safe, therefore if either the hot or the cold supplies fail, the valve will shut down and not allow any discharge from the tap. To show compliance to the DO8 specification, the company BuildCert created the TMV3 scheme, which allows manufacturers to submit their valves for third-party accredited testing to ensure the valve has the capability to adhere to the strict testing within the specification. The scheme requires the valve to be RAS approved and therefore suitable for drinking purposes, and the manufacturer to be ISO 9001 accredited to ensure they have rigorous quality processes in place. With these regulations and schemes, both the installer and the end user can feel confident in the product they install and ensure that it is fit for purpose. This brings us back to our original conflict of Legionella versus burns. Therefore, with every system which is installed and maintained, a risk assessment should be undertaken. Now let's move on to talk about the products themselves. The Reliance Water Controls range of CareMix thermostatic taps are both RAS and TMV3 approved sequential controls for use in high-risk environments such as hospitals or nursing homes to prevent vulnerable people from being scalded by hot water. The CareMix S3 is a monoblock tap designed for use on single-hole basins. It is supplied as standard with copper tails and has a combination valve to assist with commissioning and maintenance. This contains the isolation, check valve, flow regulator and strainers. The CareMix H3 is a deck-mounted thermostatic tap which would fit on a 2-hole basin. All serviceable parts, including the isolation points, are accessible from the tap itself, therefore everything can be serviced and commissioned from above the basin. The CareMix T3 is typically used in an area with a panelling system where the tap is mounted on a wall or a panel with a void behind which carries the service pipework, as is common in many commercial applications. The tap also contains all of the serviceable parts from within the tap itself, therefore you do not need to gain access behind the panel.
So let's hear a lot more about the actual features and benefits of your products.
Sure. Here we have the three models of the CareMix range. As you can see here, we have two different handle options. We have a standard lever handle, so ease of use, but we also have the extended lever handle as well. This means if a person needs to use the tap without actually using their hand, by using their elbow, the lever exceeds the length of the spout itself.
Which is good for vulnerable people.
Absolutely. Yeah. It also means that if you're in a situation where you were scrubbing up, let's say in a hospital environment or something like that, and you didn't want cross-contamination, you can actually use the end of the lever as well. All of the thermostatic controls operate from the thermostatic cartridge that you see here.
Excellent.
We use Viton O-rings, which just are the highest quality O-ring on the market. You've also got a brass stop that you can see on the end here. That means that we don't have to worry about overriding on the temperature or anything like that. It's hitting a firm stop in position there. So as we're opening the tap up, we are hitting that stop there, not allowing the temperature to increase past the set point.
So this is accessible from the top?
It is, yeah, absolutely. Everything within the cartridge is accessible, and particularly with both the T3 and the H3 models, you can do all servicing and maintenance from above the basin itself.
Oh, excellent. So I've got a question for you.
Yeah.
It's a scenario really. Imagine if a vulnerable person might have slipped in the bathroom and might grab onto the actual tap itself. Could there be any risk of scalding there, do you think?
Yeah, I mean, it was actually a main consideration for us when we were designing the taps, was that the design really leaves itself to be, you know, a grab rail essentially. If a person is wobbly on their feet, then they might lean over and grab hold of the tap.
Yeah.
So what we've done is we've actually designed a system, and I'll let that run for a little bit while we're chatting.
Okay.
So this is the hot water supply on this side and the cold on this side. What we've actually done is we have an inner pipe which runs the hot water supply into the thermostatic cartridge, which sits in the central chamber here. Now, because that inner pipe is actually not in contact with this outer surface, it means that the outer surface remains cool. In addition to that, what we've done is allowed for a bypass to come from the cold water and circulate around that inner pipe, thus meaning that the outer surface is kept cool and that it's only the cold water that's in contact with that. So if you give that a touch now, you can see that that is not heating up.
Oh, right, yeah.
And actually the same with the spout itself. Obviously that is just the same temperature as the water, which is a nice, safe temperature for the user.
Yeah, okay, that's good.
Each model comes with a flow straightener, which you can see on the outlet of the spout. That flow straightener just ensures that there is a linear flow of the water out of the thermostatic tap.
So how regularly do you carry out maintenance on these taps?
In accordance to the TMV3 scheme, you should come back to the tap 6 to 8 weeks after install and verify that the parameters are still the same. So temperature is still within plus or minus 2 degrees of what it's been set to. So on a basin that would generally be 41 degrees. And that also the fail-safe functionality still performs. So again, just isolating off on the cold and then repeating on the hot side as well. And then as long as that is within that plus or minus 2 degrees, then you'd just be looking to come back every 6 months and repeat that test. So in order to adjust the temperature, it comes back again to our thermostatic cartridge. You will see that there are 2 stainless steel cams on the top here. This top cam is the temperature setting. So you can remove that top cam, which allows the spindle to rotate more or less. And once you do that, you can then set to a maximum temperature. You just use a calibrated temperature probe under your water supply to ensure that it's at the set temperature. On a basin, we'd be looking around 41 degrees. And then once you're at that position, you just pop the cam back on and make sure it's tight up to that stop. And that is, when we open this up fully, that's the stop that you're pressing up to against there, and obviously then we're isolating off. So simple temperature adjustment through the use of the thermostatic cartridge. When the valve is in its open position, so the tap is running, You would then simply isolate on the hot water supply and ensure that the valve closes off. You would then reopen that supply, ensure that the water is running again, and repeat the test on the cold water side. Isolate off the water supply, ensure that the tap comes to a stop, and reopen it up again. And once you're reopening it up again, you're checking that the temperature is still at that 41 degrees that you've set the tap to. And then finally, it's just a case of recording those results, ensuring that you write that down so in future when you come back to do your maintenance, you can refer to those results that you have.
Oh, thank you very much. So I've got one sort of final question. You can imagine a hospital. It's really key that maintenance is kept to a minimum, downtime is a minimum. Is there any features and benefits of your product that can...
Yeah, absolutely. Most of the features and benefits that we've already spoken about, like the thermostatic cartridge that can be used on all models, the one-piece structure that we have on the H3 and the T3 models, all of that is to eliminate downtime. But in addition to that, actually on these two models, what we have is you can see that there is a join actually on both the cold and the hot water elbows here. Situated at the back are two grub screws. What we can actually do is we can isolate off the hot and the cold water supply, remove those grub screws and actually lift off the top part of the tap itself. Bring in a replacement, pop that back on, tighten the grub screws up and open up your isolation points. So if you did have a scenario where the tap wasn't functioning as it should do, then you can really make downtime an absolute minimum.
Excellent. The CIPHE would like to thank Reliance Water Controls today for an excellent Tech Talk Live on legionella and scalding prevention in commercial environments. There's 3 key points we'd like to raise here. Number 1 is risk. Always carry out a risk assessment to identify the areas which could be at risk of legionella and scalding. That's the first thing. Number 2 is maintenance. There is a requirement which is set down in the TMV3 scheme that the valve must be checked on a 6-monthly basis. And number 3 is compliance. The valve that you fit must be RAS approved and approved under the TMV3 scheme.